Hello everyone, and thanks for joining us either virtually or in person. Today, on behalf of the incredible innovation team at VI-grade led by Diego Minen and our dedicated development partners, it's my great pleasure to introduce to you not only one revolutionary new product, but two. Before I get to it, I'd like to sincerely express my appreciation for the continued support of our loyal customer base. Despite challenging economic conditions brought on by the pandemic, VI-grade's business has remained in high gear. We've taken this time to extend our lead in driver-in-the-loop vehicle simulators for product development to the point where currently our DIM 150 and 250 products outsell the competitive solutions at a 3-to-1 rate. In fact, the biggest challenge is in managing the many global installations while maintaining health and safety of our travel and our work conditions. So thank you for the trust that you've put in our team and in our technology. Now, you haven't let us rest. You've continued to challenge us to deliver ever better solutions. And today, we're unveiling the next generation of vehicle driver simulation technology. For those of you who are new to VI-grade, I think it's important to share with you the source of our passion. You see, we have a singular quest at VI-grade to rapidly accelerate innovation in the product development process. We want to move away from this old paradigm where you conceive of an idea, but then you have to build a hardware prototype before you get to experience it. Instead, we've been fixated on this idea that we can help a person go directly from a concept to trying out that conceived product virtually before hardware is built. We started by delivering real-time simulation software and then moved directly into delivering an immersive driver-in-the-loop simulator experience that allows you to actually feel the performance of the conceived product. This process is quicker, simpler, and safer, and our customers tell us that not only do they realize the expected financial return on investment, but in fact, the simulator has become a collaboration platform that unites their teams and enables design breakthroughs. For many years, the automotive industry has relied on this traditional V-shaped development process where you start on the left-hand side and you cascade design targets from a system down to subsystems and components, and on the right-hand side, then you validate and verify performance from components back up to the full vehicle. But this process isn't well tailored to modern challenges where we have highly complex interrelated subsystems like we do for ADAS. This process is too slow, too cumbersome, and much too expensive for these types of modern challenges. Instead, we've introduced this immersive driver-in-the-loop simulation technology that allows an engineer to physically drive the virtual prototype from the earliest stages of the design process, even before components are designed or selected. By doing this, we've united the work of the CAE engineer and the test engineer and significantly shortened the time that it takes to get the virtual sign-off. The ability to move directly from concepts to offline simulation and then into real-time driver-in-the-loop simulators enables us to bridge the gap between test and simulation and deliver faster innovation. As many of you have seen up till now, we've delivered a pretty extensive line of vehicle simulators ranging from simple desktop static solutions all the way up to our mid-range DIM 250 dynamic simulator. But our customers continue to ask for more. They want larger workspaces, higher dynamic performance, greater yaw and heave, and deeper immersion. And so we've broken the barriers of the previous 150 and 250 based on actuator technology and created a new line of cable-driven simulators that allow us to scale to nearly any size, from 4 meters of lateral and longitudinal travel all the way up to 15 meters and beyond. Today we'll show you the DIM 400. The new line of full-scale simulators offers a much larger range of price and performance points They allow us to perfectly address motorsports applications, extended ADAS studies, and fine-tuning of ride and handling for passenger vehicles. Even though this new line of cable-driven simulators is built on radically advanced technology, all models still share the same attractive features that you've come to expect from VI-grade simulators. That is, they're delivered as a turnkey solution with a complete software workflow. Secondly, they leverage our unique architecture where we isolate the lower stage motion from the upper stage motion so we can faithfully reproduce both low frequency and high frequency behavior. And lastly, we deliver an open real-time architecture enabling you to add your favorite third-party hardware and software solutions and have them work flawlessly. Now let's take a look at this new simulator product line, and then later the innovative new software that we're delivering with it.
Finally, the wait is over. We have now revealed VI-grade's brand new family of scalable, cable-driven driving simulators. My name is Mark Westerway. I am a driving simulator specialist located at SimCenter Udine, and I will be moderating the remaining part of this event on behalf of the whole VI-grade team. Let's now have a closer look at how our cable-driven simulator is made, taking as an example the DIM 400, the first model of VI-grade's cable-driven simulators, which is now operational at SimCenter Udine. As all driving simulator centers, our sim center features a control room and meeting room next to it. At the bottom of the installation, you can see the base frame that comes in two pieces, on which air pads are sliding smoothly. A multi-layer safety system is in place to ensure that the platform does not exceed the workspace. Now let's start to analyze in more detail the machine that has been developed in collaboration with Rebel Dynamics. First, there are 3 air pad boxes. These are housed inside the lower part of the motion platform called the disc frame, around which the cables are wrapped. The disc frame has 3 degrees of freedom: longitudinal, lateral, and yaw. These 3 degrees of freedom give to the disc frame the ability to exploit at best all the available workspace. And now let's see one of the special components of the cable-driven simulators, the inertia compensation system. The system makes our cable-driven simulators the first active simulator in the world, featuring a real separation of low and high frequencies. Through the motion of 3 calibrated masses, all vibration coming from the upper part are damped out and therefore not transferred to the lower stage. On top of the disc frame, we find the hexalift that delivers the additional 6 degrees of freedom and is characterized by top-class heave displacement and high-frequency motions in all directions. Let's have a closer look at the motions in all 6 directions. All VI-grade dynamic driving simulators are equipped with a realistic cockpit obtained from a real car. This increases dramatically the realism of the driver experience. Standard components are touchscreen, shifter, steering system and dashboard, active brake and pedals, active seat and belt, mirrors, eye tracking camera, speakers, and car body with carbon fiber components and shakers. All this can be easily mounted on top of the hexalift with a plug-and-play interface. Total immersion is guaranteed by a top-class visualization system using high-frequency projectors and a wide conical screen. As you have seen, our DIM 400 features everything you need for an unprecedented driving experience. But there's more to it, since our cable-driven simulators can easily adapt to client-specific budgetary and space requirements. They can be built in any size, ranging from 4 meters of lateral and longitudinal travel up to 15 meters and beyond. Up to 5 meters of lateral and longitudinal travel, cable-driven simulators come with a fixed screen. Above that value, the fixed screen is replaced by a dome or other visualization equipment, such as VR headsets. VI-grade cable-driven simulators are the first simulators that adapt to your needs, and not vice versa. And now, let's discover how our cable-driven simulator product line has been conceived and developed through the words of its creator, Diego Minen, CTO of VI-grade.
It was back in 2015 when we were looking for the simplest mechanical element to move a frictionless disc on a flat surface. We had a few years' experience with actuator-driven simulator, and we wanted to expand our portfolio for more application. It turned out that in order to move consistently and simultaneously along the longitudinal, lateral, as well as rotate around the vertical axis, 4 cables wrapped around 4 winches are needed. This subsystem, called this frame, represents an absolute innovation in the driving simulator engineering. We have indeed a new innovative subsystem for 3D motion as well. We call it Exalift, mounted on the disc frame and meant to capture mainly the primary chassis body motion in the vertical planes. After the initial by-hand sketches, the most important for us at VI-grade was to make sure that the mechanical system and the control system could work together. Thanks to our multi-year experience in mechanical simulation, we massively use Adams, which is the most known mechanical simulation software in its field, to simulate the simulator. MATLAB Simulink also has been used intensively to do co-simulation with Adams for the control part development. I have to say that one of the things that surprised us the most was that the setup of the parameter for the control part was used almost the same for the real machine, and this shows the goodness of the work done in the virtual world. Well, clearly nobody knew that the system was going to work. Nothing like that is, to our knowledge, present in the world. We put together an heterogeneous team made of mechanical, structural, cableway, marine, electrical and electronical engineers. We relied on mechatronics and robotics as backbone and on driver perception experience as beacon during the entire development. Driving simulator require in general a very multidisciplinary approach. We had in mind not only to design a prototype by itself, but rather to invent a new cable class simulator concept. The nature of cable allows the system to be adapted for any user requirement, both functional and logistical. Well, the cable-driven simulator is designed with having perception in mind, just like all other VI-grade simulators. In particular, we have 2 stages of motion, one for low frequency and big displacement, X, Y, and yaw, and another one for high frequency and small displacement, like X, Y, yaw, as well as for low and high frequency roll, pitch, and Z. The associated inertia of each stage are inversely proportional to the frequency that they've been designed for. Moreover, cable-driven has an independent combination of X, Y, and yaw, meaning that there is no limitation for the motion independency of each of these axes, and only a slight dependency on the Z travel on the other directions. Those characteristics allow for very adaptive motion QE setting, fundamentally for any truck, any car, and any driver, and this accelerates dramatically the tuning process. Well, there are a few. I would list them as balancing of motion envelope versus perception, total or very high independence of motion degree of freedom, absence of actuator noise and vibration, low energy consumption compared to performance of the machine, definitely low weight, simple mechanical installation, and tolerant requirement. This type of simulator does not require an extreme precision for installation due to the nature of cable, and this would go together with clearly huge stiffness, high inertia, extremely high power requirement. Most of the machines similar in terms of workspace have high frequency motion vibration from simulator of contact and actuator dynamic, and these are transmitted undamped through the whole kinematic chain and obviously bounce back very unrealistically to the cockpit. It cannot be summarized precisely in a bullet point, but the cable-driven simulator is passively overdamped for planar motion, of course due to the polyethylene cable, and is actively damped for the high frequency generated by exhalative motion. A special subsystem called inertia compensation system acts as at source vibration cancellation for any potential undesired cable oscillation. It turns out that thanks to the inertia compensation system, it is possible to optimize the the simulator performance on the two stages harmonization in a spectacular way, tuning it depending on payload inertia.
Thanks to Diego Minen, we have gained a unique understanding of the main capabilities of our brand new cable-driven simulators. Let's now experience how they perform through the words of professional racing driver Marco Bononomi.
Wow, just another level. Well, first impression is just wow. It's just amazing feeling, and I have to say it's a really big step up compared to the previous models, because right now with this platform we can produce much more movement and faster, so it's just great, and for sure will help to develop in an easier way and a faster way all the products or the machine. Well, the gap for sure is getting closer and closer, and especially after driving this great platform, I can confirm that, and you can see also in the general situation with all the factories that yeah, they always invest more and more on simulation, because of course it's a big investment at the beginning, but then you can produce closer data and testing. You can test much more compared reality, of course, and you can validate so many things that in reality you have to wait maybe 1 year. So in this kind of things, simulator can give you a lot of things, and here with the new product we can be very precise on the target. The main advantages are you can see it produces a big view that never ending. It looks from inside. Plus the movement is longer and more. For example, when the car is sliding and sideways, the feeling is just natural. Plus also vertical movement. I felt it a big improvement on that. It's more reliable. And also one thing that sometimes we forget is very silent. So inside of the cockpit you feel more natural, and you feel more in the natural environment of a car. So today I can say that with this machine, driving simulator and testing are closer than ever.
It was very exciting to see Marco Bononomi driving our cable-driven simulator to its limits. Before we say goodbye, we have one more very important announcement to make. VI-grade is rolling out today another major product line extension, which will further complete the company's portfolio, both for offline and driving simulator solutions. Please welcome Guido Bairati, VI-grade's Vice President for Sales and Marketing, who will introduce our brand new high-resolution graphic environment for accelerated vehicle development.
Today, until now, we have seen how much care and attention VI-grade is putting into R&D activities to provide the most sophisticated and realistic driving simulators. VI-grade clients are always looking for solutions that allow them to develop innovative products in less time and with less risk. And this is our main driver for R&D activities. When it comes to driving simulators, we have always to remember that these machines are a well-balanced mix of hardware and software. To deliver a realistic experience to the driver, a driving simulator requires a software stack that provides reliable information on how the vehicle behaves, how tires interact both with road and chassis, and how the external environment is defined and rendered. In motorsport, being able to train on a circuit and try various setups before a race is key for success. Testing is limited and very often banned. Even when there are track tests, testing can be difficult to carry out. Therefore, having the right representation of track models on the simulator is very important. In chassis development, being able to fine-tune suspensions, tires, and other components on different virtual proving grounds is very powerful to decrease time to market and to front-load problems and develop innovative products. Today, ride and handling development is done mainly on the driving simulator before building the first physical prototype. In ADAS and autonomous vehicle development, it's all about perception, prediction, and planning. And public road driving has exposed all challenges of testing ADAS and autonomous vehicles. Therefore, being able to test on a simulator with a high-definition environment is vital to develop, test, and verify these systems safely. For this reason, today we are introducing a brand new graphic environment that, from now on, can be used on all VI-grade driving simulators. It's time to introduce VI-WorldSim, a high-resolution graphic environment for accelerated vehicle development. VI-WorldSim gives the possibility to drive a vehicle on a driving simulator in a high-resolution replica of the world with realistic traffic behavior. This new graphic environment is fully integrated with VI-DriveSim, easy to use, giving you the ability to build rich, realistic, and interactive scenarios without any programming knowledge, and highly realistic as it is based on a real graphic engine. VI-WorldSim gives you the freedom to define any type of environment. Racetracks for vehicle development and driver training, CAV test sites for ADAS and autonomous vehicle development, testing and verification, and public roads for replicating real-life scenarios. And then it's possible to add traffic, pedestrians, lighting conditions, weather conditions like sun, rain and fog, and sensors. And all this makes it possible for you to simulate your scenarios in any driving simulator. If ADAS is your focus, then VI-WorldSim also comes equipped with the latest Euro NCAP 2021 test, already pre-configured and saved in a library for you. Just click on the test you want to perform and go. VI-WorldSim gives our users one single graphic software for all different types of environments, all different types of simulations, all different types of disciplines. For more information, please visit our website and the dedicated webpage vi-grade.com/WorldSim.
Before we proceed to the Q&A section, during which you will have the ability of asking questions to the VI-grade team about VI-WorldSim and our cable-driven simulator product line, let me invite you to visit our homepage for a detailed overview of these solutions and to request a one-to-one session with our experts to better understand your needs and plan together with us a roadmap to the implementation of these solutions. For your convenience, a recording of the event will also be made available on our channels. With that, on behalf of the whole VI-grade team, I'd like to thank you all for joining our virtual event. The revolution of driving simulators is now.